Okay, we're moving on to inequalities today. And while the lesson today is very, very simple, I want to take it a step further. I want us to be able to start analyzing using graphs. Okay, getting ahead of myself. We're doing inequalities. And the first thing I want you to be able to do is tell the difference between greater thans and less thans without using that stupid alligator eats the bigger number jargon. Oh, it just, as my grandmother would say, burns my biscuits when people say that. I don't know why they didn't have faith in you that you could have discerned a greater than sign from a less than sign. It's very simple. We read from left to right. This is the word greater. It is not the word returg. So likewise, we're going to read these signs from left to right. And you see the bigger end first, signifying greater. Here you see the little end on the left side first, signifying less than. So of course, there are four types. There is a greater than sign. There's a greater than and equal to sign. There's a less than sign. There's a less than or equal to sign. All right, let's move those out of the way. Make little faces with them. And let's look at our example. What we're going to work on today is just testing to see which number makes the sentence true. Now remember, that's big in math. When we analyze something, we're looking to see whether it's true or false. That's what the whole world evolves down to. Think about research in medicine. True, this medicine I've developed will help. False, it won't help. Sometimes there's true with some false benefits. Like this medicine will help you, but there are these side effects. But everything boils down to true or false. All right, so we're going to test. So I've set up a little template here. And they want us to test for these numbers. All right, so the first number they want us to test for is 10. All right, we should be very adept at doing our math here. Well, 10 minus 2 is 8. 8 times 3 is 24. 2 times 10 is 20. 20 plus 1 is 21. Is 24 greater than or equal to 21? Absolutely, it's greater than. So that works. How about 5? Let's put a 5 in here. 5 minus 2 is 3. 3 times 3 is 9. Is that greater than or equal to 11? Nope. 9 is not greater than or equal to 11. It crosses off. 1. Let's put a 1 in here. 1 minus 2 is negative 1, so this becomes negative 3. Is that greater than or equal to 3? No. That doesn't work. So you can see today's work is really, really simple. They're just still working on truth values. Well, let's just take this one step further. 5, 15, greater than or equal to 2 times 7 is 14, 15. Is 15 greater than or equal to 15? Yes. So out of these certain numbers they asked us to test for, 2 were right. Now, yeah, we can solve this and we can find out what answers work because when we have inequalities, there are often infinite answers. And it's impossible to test every number in the world to see if it works. So tomorrow, as you can imagine, we're going to solve this. But right now I want to look at my friend Desmos. So what I'm going to do here at Desmos is I'm going to type in each problem. So first I'm going to type in 3x minus 2. And that becomes a red line. And then over here, I'm going to type in 2x plus 1. What happens is we get two lines, a red line and a blue line. Now I'm going to move this to see where they cross. And they cross right here. Okay, so I took a screenshot of the Desmos and I brought it over here so I could work with it. Notice we have the red line and we have the blue line. Well, this was asking me, where is the red line greater than or equal to the blue line? And greater than means above. Where is the red line above the blue line? So we can solve it mathematically, or we can look at a graph to help us. And nowadays, we're looking more and more at graphs. Graphs we look on architects' plans, engineering plans. It helps us predict the future. So we want to get sure that we can read and understand all graphs. And once again, notice it's only asking us about the x values. We don't care about the y values. Well, look at the point right here, 7. 7 is the point where the red line equals the blue line. Now above, see now how we move and the red line is now above the blue line? And well, what x values make it go above? Well, here was 7 right here. And if I drew this line, this is the line where the x values are always 7. And here's the line where the x values are always 8. See, if I put 8 into the problem, this is what I get as an answer. And 8 on the red line is definitely above the answer I would get on the blue line. Likewise, if I did 7.5, which is right here, it looks to be right there, the 7.5 answer on the red line is definitely above the 7.5 answer on the blue line. So we're going to learn tomorrow, when we go to solve this, that the answer to this question is actually any x value greater than or equal to 7. And isn't that what we saw? See, 10 is greater than or equal to 7. 7 is greater than or equal to 7. And then these numbers right here were not greater than or equal to 7, so they didn't work. And there's an infinite amount of answers. Look, any number greater than or above 7? Oh my gosh, that's infinite. All right, so just to run through a few more real quickly. Right here, they're asking us to determine if the value of 2x plus 4 will end up being greater than 4x minus 1 if we put in 1 for x. Well, kind of boring, kind of easy. This 6, this is greater than 4 minus 1 is 3. Is 6 greater than 3? Yep. All right, well, again, I want to look at it at Desmos. That makes it a little more interesting. So I've got my lines here. I've got my red line, 2x plus 4. I've got my blue line, 4x minus 1, and they wanted me to look at the value x equals 1. So that's what the green line is. At 1, is the red line above the green line? Yes, and look at the answer, 6 and 3. Where do they equal? Right here at 2.5. But that's not what the question asked us. It just simply asked us, is x equaling 1 a viable solution for this? Yes, it is. All right, example 3. Negative 3, in for x, we're put negative 3, greater than or equal to, wow, I have this obsession with greater thans in this lesson, negative 3 plus 7, that quantity gets divided by 2. Well, negative 3 plus 5 is 2. This is negative 6. Is that greater than or equal to? Well, that's 4 divided by 2. 2. No, it is not. So this is a false statement. This will not be true if we substitute x equals -3. All right, let's look at Desmos for a second. All right, when I go to Desmos, I can see -3 quantity x plus 5 is the red line, and then x plus 7 quantity divided by 2 is the blue one. So they wanted to know, is the red line above the blue line when I go to when the x value is -3? Well, when the x value is -3, the blue line returns 2, and the red line returns -6. So no, the red line is not above the blue line, it's below. So that's why we got no. So it's kind of cool looking on Desmos. All right. So tomorrow we got a little more complex ones, and that's when the less than signs come into play. Okay, guys, see you tomorrow.